Hi everyone, we're going to try this out as something to see if it might work for future lessons. The assignment you're going to have for the next couple of days deals with systems of equations, which should be review. We're talking about linear equations here, things that are going to be in the form of y equals mx plus b. And we're going to talk about the ways we have to solve these. There's three ways. Think about it for a second. Can you come up with those three ways that we've solved linear systems in the past? Let's see. Let's make sure we've got them. So graphing was one way. And I know we all hate it. You only have one of these on your assignment, I believe. You're going to graph each equation. Again, they're linear, so you're going to have y equals mx plus b. And you want to find where they intersect. That's that point, the x and the y, where they intersect. That's the solution. That's part of the reason why we graph, is so we get a visual picture of it. Substitution is where you're going to solve for one variable, and you take that new equation, once you solved, and you plug it into the other one. Then you do some distributing, combining like terms, solving, you get your variable, and then you go through and you get your second variable. You always want to have an x and a y. Remember, all our answers, ordered pair form, x and y. The last way is the way that hopefully we focus on the most, because this helps us when we get to systems that have three or more variables. It's elimination. We line up the equations vertically, one on top of the other. We use multiplication to get either the x or y to match, but have different signs. Once you do that, when you add the equations, one will be eliminated. You take that new answer you have, so maybe something like x equals 7, and you plug it into one of the original equations to get your second variable. Now take a second and see if you remember, it wasn't always an ordered pair as an answer. Sometimes we did get a special case. There were two special cases. You know what happens if the lines don't intersect? The lines don't intersect, they may be parallel. That's going to be one case. The other case is if the line is the same line for both equations. Well, if the lines are parallel, let me figure out how to move these. If the lines are if the lines are parallel, the special case is no solution. If it's the same line, it's infinite solutions. So no solution, parallel lines if you're graphing. And for infinite, it's the same line. All right, let's look at one of each of these methods. So let's start off with graphing. So I've already got these in slope-intercept form. You may have to do some solving first to take care of that. So this first one, my b is 8. So I go up 8 on my y-axis. Remember, you always start on your y. Slope is -4/1. Remember, slope is rise over run. Since it's negative, I go down 4, but I still go right 1. 1, 2, 3, 4, right 1. Well, I didn't count that right, did I? I don't have you here to help me. There we go. 1, 2, 3, 4, 1. And we don't know where these lines may intersect, so we want to keep going. And I'm going to wait a second to connect them. I like to get my dots in first, especially if my line's maybe a little bit longer and I can't see. So this one I'm going to start at -6. And then my slope is positive, so I'm going to go up 2, still going right 3. Oh, that's where they're going to intersect. Might get one more point up there to make my line a little bit straighter. Heck, I'm going to give myself a fighting chance here and use that tool. And so I do want to finish by connecting those, and don't forget to write that ordered pair answer. 1, 2, 3. So my x value is 3. 1, 2, 3, 4. -4. That's my solution. Then we moved on and we talked about substitution. Substitution, a lot of times, it helps to go left and right. Well, it looks like I'm going to have to do this in two parts, so hang on right there.